Let's kick this off. This is a Kahoot by me, Keith Barker. I'm so glad that you're here. Reading a routing table, November 2020 edition, 3, 2, 1. And here is your first question. For a packet that is being sent to 10.2.6.252, what is the next hop or the next router in the path? Let's take a look at the answer together and why it is true. So for a packet going to 10.2. What was the address? Hold on a second. 10.2.6.252. Basically, there's only one route here that matches that. That's this guy right here. So the first 3 octets, 10.2.6 is the network. So based on that address, this is the correct match. And so as we look at across here, this number right here is the administrative distance. Now, it's really important. I mean, it's critical to realize 2 things. Number 1, routes have to get into the routing table. So if you have 2 different routes that are trying to get into the routing table, one's a static route, one's directly connected, one's coming from OSPF, one's coming from BGP, and it's the exact same network, which ones get in? And that's always based on AD, administrative distance. And it's like golf. The lower the score, the better. And so as we play golf, as we play administrative distance, if there's 2 different protocols, and one has an AD of 110 for that exact route, and one has an AD of 120 for that exact route, the lower is going to get in. Now, once it's in the routing table, which is right here, then when a packet comes along, the router always looks at the longest match to see which route's going to be used. So this is the only match. In our case, this is the administrative distance. This is the metric. It's funny that we have different words for different things. So sometimes they call this number a metric, depending on the routing protocol. In OSPF, it would be called cost. And if you're running RIP, like it'd be hop count. And the next hop is 10.2.46.6. And the egress, the outbound interface, is serial 3/1. So if you're a visual learner, like I am, it would look like this. We'd have a router. It would have an interface, serial 3/1, right there. So a packet's coming in some other interface, we don't know. And it looks at a routing decision. It says, boom, I'm going to send it out serial 3/1. And the next hop address is going to be 10.2.46.6. If this is router 1, this is going to be router 2 right there. But if it forward it, R2 would grab that packet, make a forwarding decision based on its routing table, and it would continue to forward along the network. Are you ready? Here we go. Next question. Hang in there. You're doing great. Keep studying, keep labbing up. Now, in this quiz, the opportunity to win increases as you answer questions correctly and you do them faster. And if you get more questions in a row, they stack up, you get more points that way as well. So feel free to do that. Also, I've got like 140 CCNA related videos that I've just placed on YouTube in the last like 14 months. So if you haven't already, take a moment, click on subscribe to make it easier to find me. And if you're studying for CCNA, whatever you're using for your main course of study, whatever that is, great, get that. And then as you study topics and you want a clarification or more details on it, come visit my channel. Just grab that topic that you're currently studying and get some reinforcement for it. Where does the longest match rule apply? All right, when choosing a route from the routing table. And the secret here is that routes have to win twice. It's not fair. Just think about if you are a route, it's just not fair. You have to win twice. You have to get into the routing table. And the way you do that is you have the better administrative distance, lower, like golf, lower is better, than your competitors. So if you have a lower administrative distance than some other routing protocol or some other option, then you get into the routing table. Okay, boom. Now, just because you're in the routing table doesn't mean you're going to be used. Once in the routing table, it's always the longest match. And what that means is if there's a packet going to 10.2.3.4, some IP address, some unicast address, the routing table is considered and looked at all the routes in the routing table, and the one that has the longest match, meaning the most number of bits match, is the one that's going to be used. So AD to get in, longest match to be actually used from the routing table. Here we go. Question 3 of 12, double points, no pressure. What is the metric of the route used when forwarding a packet to the IP address 10.1.5.39? Now, the deal with a question like this, which 57 people got correct, great job, is that in the exam, in the certification environment, they're not going to give you a chance to justify why you chose the answer you did. frankly, they don't care. It's just it's just a computer exam. So there's no way of actually talking your way out of this in an exam. And so you need to get most of the questions correct in a certification exam. So let's take a look at this together. I'll do it right along with you. Let me bring up the full screen. And what is the metric of the route used when forwarding to 10.1.5.39? First question that we might ask ourselves is, what route are we using here? So it could be this one. I'm just eyeballing it here because that last octet is 32. But let's check that out. I want to verify that that's the route before I start answering the question. So even today, I'm not afraid to share this with you. As a double CCIE and having certifications from a lot of vendors, I would still have to just do this manually to figure out what the range is for this route. It's really kind of like a subnetting question. So a /28, if we're looking at the fourth octet, 128, these are the values of the bits, of those bits. 64, 32, 16, 8, 4, 2, and 1. I got a text this morning from Eric, who lives here in Vegas, and he is an audio engineer, amazing one at that, and he has started studying his subnetting and stuff. And he says, "I'm taking your Subnet Saturdays course. I'm calling it Subnet Sundays," because he does it on Sundays. And I'm just so proud of everybody who's taken the time to learn it. And that's a great course. If you need to learn subnetting and you want to really be competent at it, that's a great way to do it. Subnet Saturdays, the free playlist here on YouTube. Okay, so this last octet is a /28 mask. So this is the 24-bit boundary, 25, 26, 27, 28. All right, boom. So everything to the left is network. Everything to the right is host. If you're like, Keith, what the heck does that mean? Check out Subnet Saturdays, and you'll be right up to speed. So the block size is 16. So the subnets for this last octet, well, if that's the 32 network, this is the routing table. The next subnet is going to be plus 16 more. So I'm going to add 16 there. That's 8, 48. All right, that works. So this network right here, 10.1.5.32, has a range of valid, basically 32, which is the network, all the way up to the next subnet, which would be 47. And we are trying to get to .39. 39. There we go. So that's the route, in my opinion. I think that's the route, unless I'm totally wrong, which we'll see here in a moment. So all the details about this are: this is the AD, which is the AD for RIP. Great job. And this is the hop count, or the cost. And this is the next hop. And this is the egress or exit interface that we're going to use to reach that. So let's hide that for a moment and look at the actual answer here. 1, yeah, that's the metric. The AKA cost metric, hop count in case of RIP. So that's why that's accurate. Question number 4 of 12 is a puzzle. Double points. Place the routing protocols. Do this carefully based on administrative distance from the most preferred to the least preferred. So with most preferred, really this reads lower AD to higher. So internal EIGRP has an administrative distance of 90, and OSPF has an administrative distance of 110. ISIS, depends on what the meaning of is 115, and internal BGP, which is terrible, is 200. If I didn't already mention it, it's great to have you here. Thanks for joining me for a few minutes for this quiz. And Helpful Leopard is on the top of the heap. Way to go. What is the cost of the route for 10.1.57? Now, that's the literal route. You don't need to figure out what route's going to be used. I'm just asking about that specific route. So here's 10.157. There's the route right at the bottom there. AD is 110. The cost, or the metric, is 3. Next hop is 10.0.34.3. And the egress, the interface it's going to use to send it out, is going to be fast Ethernet 4/1. Now, one of the thoughts might be, well, holy shnikers, it's every time a packet comes in, it's got to look at it, look at the routing table, make a decision. No wonder it's going to be slow. Well, for the last decade or so, Cisco routers are caching all of that in memory with Cisco Express Forwarding. So everything about where this is, this route, and who the next hop is, and what the layer 2 address is, and everything else, it's all cached, ready to go. So when that packet shows up, this router says, I got this. And boom, it's all pre-calculated. Also, another really cool technique. If you're on gear and you have a packet like for 10.1.57.90 and you're wondering which route is it going to take from the routing table, you can do a show IP route, put in the 32-bit destination address, and it will show you in detail which route it's going to use from the routing table. And that way you can verify your guesses and predictions. In the certification exam, they're going to want you to know this, which is cool. But you can actually verify it if you're doing labs with live gear or simulated gear. All right, next question. The gateway of last resort is referring to the default route. Is it true? Is it false? So the gateway of last resort indeed is referring to the default route. Question 7 of 12. How was the route to 10.1.5.0, the 27-bit mask? How was that learned? How was it injected and put into the routing table? Who caused that? How was the route to 10.1.5.0.27 learned? First of all, let's find it, shall we? Let's find it. 10.1.5.0. That's the route it's talking about, so it's not asking us to determine which route. That's it. And there's the AD of 20, which belongs to external BGP. There's the metric of 0, and there's the next hop. So in answer to this question, it is external BGP with the administrative distance of 20. Now, the question may come up, and it came up yesterday in the office hour on Discord, where I was like, oh, what are the gotchas? The blueprint from Cisco, the exam topics are very, very, I thought, fair for the exam. It's going to ask you about configuring, describing, explain, etc., all these topics. And the one that caught me by surprise a little bit, and I made a video on it, was a routing protocol. It starts with an E and ends with a P. And it's EAGRP. I was going to say that's also external BGP, but EAGRP, you want to be familiar with the basics of it? I've got a video on my channel about EAGRP, even though it's not explicitly on the blueprint. Also, administrative distances from other routing protocols like ISIS, external BGP, internal BGP. You don't have to know BGP, but it's good to be aware of what the administrative distances are. And that way you can predict what routes will make it into a routing table based on where that route came from. Here's your next question. Double points. Place these in the correct order. Oh no, another drag and drop. So place these in the correct order as far as when they would occur. Let's start and talk about why this might be the first thing. Router places the route in the routing table. That's all based on AD. There's really 3 basic ways that routes can get in the routing table. That's really it. 1, they can be directly connected. Think about a router that's like this guy right here. So you've got a router. It's got interface gig 0/0. We put an IP address and a mask with that IPv4 address on that interface. And boom, if this is the 10.2.3.9 address that we put on with a 24-bit mask, this router on that interface that says, oh, 10.2.3.0/24 is directly connected. And that would show up as a C in the routing table. So that's one way. Another way to do a route in a routing table is static routes. These are painful. I'm just going to tell you straight up, sometimes needed, but painful. You got to go into the router and say, dear Mr. Router, to get to this remote network way far away, I need you to go ahead and use this next hop address. And if you're not using serial, using Ethernet interfaces, put the IP address in that static route, not just the exit interface. Put the IP address. If you want to also put the egress interface, you can, but you don't need to. Just put the IP address. That's the safe way to go. But a static route is the second way. So 1 is directly connected. This will show up as a static route if we add one. And then third, which is the most popular option, is some type of dynamic option. DYNAMIC. I just graduated from spell and talk at the same time school. But dynamically. So we could learn dynamically through a dynamic routing protocol. There's other ways to learn dynamically as well. But like OSPF would be a great example of a dynamic routing protocol. And so if we had the same route 10.2.3 that was directly connected and a static route for 10.2.3 and a dynamic route for 10.2.3, this guy is going to have an AD of 0 because he's directly connected. The static route is going to have a default AD of 1, and the dynamic route, if it's OSPF, is going to have an AD of 110. And which one's going to win? The directly connected because of AD. Boom! Router places routes in the table based on AD. Then when a packet comes to the router is going to use the longest match, and this is the only route it's going to have in the routing table, the 10.2.3 network, which is directly connected. So it's going to use the longest match. And let's say there's a packet, so that's check next. Now, if a packet's going to, let's say, 23.9.6.4. If a packet's going to 23.9.6.4, router's looking at the routing table. It's all cached, but it's looking at the routing table, and it's looking for the longest match. If there's no match at all for a specific route, if it has a default route of 0000, think of a zero, like with the zero mask, that is the last ditch effort. And then the router will go ahead and choose that if it couldn't find a longer match in the routing table. So that's when the default route is used. If there is no default route, this packet to 23.9.6.4 is going to be dropped, and that's the order. Do me a huge favor. Give me a quick chat and tell me what part of the world you are currently viewing this from. You can do your city, you can do your country, you can do your hemisphere, continent, I don't care. I'm very interested to always see the breadth of where we are coming from as we gather together to learn more about Cisco and various technologies like routing tables and what have you. So also, this is a good opportunity now. If you haven't already done so, to click on subscribe. Just makes it easier to find me. You go to your subscriptions and say, oh yeah, there's Keith, and you can join me. That way, as you're studying CCNA, it makes it very easy to find. Also, my playlists are very, very useful as well. What is true about the route used to reach 10.1.5.50? So imagine a PC or a server at the IP address 10.1.5.50. Which route in this router's routing table will be used to make that forwarding decision? All right, well, the correct answers are red and green, but here's how I would solve it. If our destination, our goal, is to get to 10.1.5.50, the first question is, which of these routes is going to do it? So I'm going to say all these routes that have 0 here, and definitely that one's not going to work. Oh, and the third octet here of this guy's not going to work, and this guy's not going to work, and this guy's not going to work based on the third octet. Okay, so all these 10.1.5s are possibly, candidates. I'm just ruling out what's not going to be used. So let's do the math here real quick, and let's see. I know that 10.1.50/24 matches. That's because 10.1.5, the first 3 octets match. But let's see if 10.1.50/27 matches. So, and also 10.1.5. Dang it, Keith, you're going to make us work here. Yeah, I am. So I'm going to take a stab at this one. Let me just do this real quick. 28-bit mask, 128, 64, 32, 16, 8, 2, and 1. 1, 2, 3, 4, 5, 6. Yeah, missing 1, missing 4. That's important. Okay, and I'm dealing with the 4th octet here as I look at 28. And so with 28 is 25, 26, 27, 28. Block size is 16. This is all ringing a bell. So that would be the 32 plus 16 more would be 48. Oh, that doesn't reach. So it's not this route, because this route, its range is only 32 through 47, because the next subnet is 48. So it's not that one. All right, let's take a look. Oh, and here's a 32-bit route. That's not going to work. And now it's between the 27 and the 24. So on the 27, I'm just going to put a /27 here. 25, 26, 27. That means the block size is 32. That means for this guy, it'd be 0, 32, and then 64 for the subnets, and he's in subnet 0. That goes up to 32. So that's not going to fly. That doesn't match. So then we have this guy, 10.1.5. That's our route. That's my thinking anyway. We'll see if the answer is correct. So 10.1.5 is the route, and the AD is 110. The cost is 3. The next top is 10.0.34.3, and the egress interface, that's a fancy way of saying the exit interface it's going to use, is fast Ethernet 4/1. Let me hide that for a moment and see if any of that makes sense. The prefix is 255.255.0. Okay, that's a 24-bit mask. Perfect. And the AD is 110. And it certainly is. Okay. I'll take it. I'll take it for the win. Now, in a question like this is really just trying to determine if we get it, right? And the actual certification exam really also, in my opinion, does a fair job in asking and confirming, do we get it? Do we understand how it works? And they could ask us any part of a routing table that they expect us to know, and we should be able to answer it. And the thing is, don't hover on that shore too long. Don't wait on that shore, that riverbank too long. If you answer a question, take the next one, and the next one, and the next one, and get your CCNA, and then move on to the next thing. Everybody's a winner just by participating. I'm glad you're here. Come see me on my office hours on Saturdays at 10 a.m. if you have other questions. Okay, Place the routing protocol codes from the least preferred or the less preferred to more. And this is a question once again about AD. With RIP, it is 120. I pause because I think about it. I, which is ISIS, is 115. O for OSPF is 110. And C is directly connected, and that's a default. Oh, directly connected is 0. And a static route has a default AD. If we're pointing to the next hop address as part of our static route, it has an AD of 1. Okay, what is the mask for the route to 10.1.5.32? All right, great job. 67 of you said 255, 255, 255, 240, and that's because it had a /28-bit mask. If you want to do it in binary, either way, but so this is the third octet boundary between third and fourth right here. So 128, 64, 32. I really don't need this for this, but we're going to do it anyway. 8, 4, 2, 1. One of the benefits of writing this out is just gets your brain in that pattern of, okay, I got this. So a 28-bit mask would be 25, 26, 27, 28. There's the new dividing line, network to the left, host to the right. Block size is 16, although we don't need that for this question. And the question is asking us about the mask and what is it in decimal. So you could just say, well, it's going to be 128 plus 64 plus 32 plus 16. So if we wrote those out, that would be something like 128 all by itself. This would be 192. This would be 224. This would be 240. So you don't have to have those memorized, but you should be able to add them up if you need to. So 128 plus 64 plus 32 plus 16 is a total of 240. Anyway, you want to get there. And after you work with IPv4 for a while, you'll start to memorize or recognize some of those. But I do want to point out that, let me bring this up. Even if you're really comfortable with the masks and everything else, just do the math. If you have a question or two in your certification journey, just do a quick verification with the math to make sure it's right. Because if I was writing a couple quiz questions regarding subnetting, I would make them look bad. I would make them look like, oh, there's a 255 in that last octet. That can't be a valid IP address. Oh, yeah, it can. What if it's a /23 and we have a bit off in that 24th bit, which is a host bit? Also, I want to point out that for certification, I want to give a shout out to the, more than a handful of people this week in the last 7 days who've passed their CCNAs. Congratulations, way to go. Keep on moving. Also, for the quizzes, if you've taken the exam once and you go back and take it again, here's what I would do if I was a quiz writer. I would write a quiz question, and I am a quiz writer, I guess, for these games, but I would do a quiz question, and that'd make like 5 variations of it. And in those 5 variations, I could have different answers or looking for different things. And so if you're taking this exam more than once, which I hopefully you won't have to, just take it once, study, prepare, and nail it. But if you take it more than once, if you get a question and you think, oh, I know this one, and you answer it, just be aware it may be the same question, but probably isn't. So it may be a question with the same topology or the same wording or the similar wording, but just make sure you look at every single question. And with subnetting, do the math. Just do the math as far as what ranges, what routes, and so forth. And that way you can make sure you get it correct, including if they throw you a question that looks like, what? How does that work? Just do the math and make sure you're correct on them. This is our last question. No pressure. But this is for all the marbles. Double points. R1's OSPF neighbor is about to advertise this network. What happens after it does? I'm also implying here that we do have a neighborship between R1 and its neighbor that's working for OSPF. So R1, so we have R1 here, and we have R2. I'm going to say R2 is the neighbor. We don't really know who the neighbor is, but it's a neighbor. And it's got this network 192.168.1.0 with a 24-bit mask. And so that gets advertised. R1 sees it and says, oh, I'm learning this via OSPF, so the AD is going to be 110. It looks at its current routing table and says, I don't have a route for this 32-bit or for this 24-bit network, 192.168.1. There's no problem. I'll add it. Even if the AD was like coming from another routing protocol, even if the AD was 200, like from internal BGP, there's no conflict here. We don't have a 192.168.1 network with the 24-bit mask. If it's 254 even for an AD, it would still make it in because there's no competition. It would get in. And then when a packet comes along, it would always be based on the longest matching route in the routing table. So I'm curious how we did on that last one as far as who got it right. Let me go back and take a look. 49 of you got it correct. Nice work. And it's that moment. Drum roll, please. I'm going to go silent as we enjoy the music and enjoy the podium. Snowy Lion, third place. Friendly Seal, you did it. It pays to be friendly, pays to be nice to everybody, and also pays to know how to read a routing table. So let me do a couple last things, and then we'll say goodbye. Here are the toughest questions in this quiz. If you have any questions about what you're studying and you want a clarification on something, join me for the office hour every Saturday, 10 a.m. Pacific time. I'm here. It's in the Discord server. The link's in the description of this video. Feel free to join me. I'm going to jump into the Discord server in the CCNA voice chat room in just a few minutes. But before I do that, let me go ahead and let me bring up some questions. Let me go ahead and change my camera here. Not there. There we go. All right. Hello. And let me just go and see if there's any burning questions here. We'll just do this for a few minutes, and then also we'll jump into the Discord server. Also, just so you know that I will be editing this video, and it's going to basically chop it down into manageable chunks. And so later, if you want to go back and review this, it'll be in my playlist for quizzes. It'll be the shortened version with about 30 minutes of content, the question, like a 5-second timer, countdown, the answer, and then the explanations. And also this is such a great idea. It was Luke and Morgan and others who helped me see the light in this and recommend it, was to go ahead and put timers. So if you're watching on YouTube, you can actually just skip to the questions, like question 1, question 2, question 3. And that way you can jump to those questions very easily and make it more useful for your time.